So I've been trying to use FreeCAD lately, which is an amazing piece of open source computer-aided design software. And it's a great tool, but it's got a lot of different workbenches and tools inside the workbenches. It's not easy to learn if you're a new user, and the YouTube videos that are tutorials are just amazing. In particular, JOKO Engineering Help has a whole series of really great videos, and I am super grateful for the hard work that went into producing those. And I worked through this particular one, which talked about how to create this sort of cylindrical grid of hexagons, and as I worked through the steps in his process, which he goes through in great detail, and it's really terrific, I found one conceptual error that he made, and then he made one design choice that was fine for what he was doing, but it didn't work for the process the problem that I was going to do. And I thought it might be an interesting, instructive kind of thing to do a comparison video on. I ended up scrapping his thing and doing my own process that was similar but different in various ways, and to kind of be able to compare and contrast those things. So let's get into it. And I'm going to turn off this geometry and sort of do a lightning round. I don't want to recreate what, or just show you what he did, because his video already does that better than I could. But so we're all on the same sheet of music. He starts off by defining a wedge that is effectively 12 degrees wide, because he knows that's a 30th of a circle. And he defines a datum plane that's orthogonal to that, so that he can draw these sort of a pair of hexagons. Let's turn those on, and that are sort of, perpendicular to that. And then he can do an extrusion to kind of create hexagonal prisms. And then he takes his original wedge, and he's going to extrude that in the sort of z dimension, so that he creates this sort of Pac-Man-like shape. And then he can do a cut to create a truncated prism. And we're going to turn off this, and he ends up with this sort of pair of truncated hexagons, which he can then do an orthogonal array to create a stack of them, and a cylindrical or a polar array to create his final shape. And that's kind of the lightning version, and that's great. One thing that's sort of the conceptual error that he made is, if you go back to his original sketch of the hexagons, what he does is he's defined this wedge to be basically, that's supposed to be the left and right bounds of his repeating unit, and then he uses that as the left and right bounds of his sketch, which sounds good at first, but if you really think about it, anytime you're designing a repeating pattern, you don't want it to fit within that repeating pattern. What you want is for a point on the pattern to be repeated at the same point on the next iteration of that pattern. And so as I've drawn this sketch here on the screen, that's fine. That's true. But see, he's effectively choosing this outside corner here and this outside corner here as his repeating unit. But if I were to have changed the gap here, you'll notice that the actual repeating point, that's the same point on the next iteration over, is from this point to this corner here, not to that corner there. And so depending on the value of the gap, there is a Goldilocks value, which I kind of started off at, where these two things are exactly the same. But if you chose a smaller or larger version for the gap, those two things would not be the same. And so what does it matter, right? I mean, if the gap disappears altogether, it's like 15% off. And if I sort of scroll up, I've actually got that other measurement here. So if I sort of bring this all the way down, you can see that can get down, without me overlapping the hexagons, it gets down to about 85%. So if this gap were to be smaller, let's say, and I close this out and I come back to his final design, if I zoom in, you'll notice that the gap here between these hexagons is fine, and sort of neighboring gap here is the same. But then there's this is the pair that he drew. The next pair over, the gap is too large, right? And that's because he's chosen where to repeat his pattern in the wrong place. And so the lesson to draw out of that is just, anytime you're designing a repeating pattern, make sure that you're repeating it based on a point on your design and then the same point on the next iteration. Otherwise, you can get the spacing right. If you don't sort of carefully think about that, you can end up with this sort of artifacts here. Now, the other problem, like the design decision that he made that I thought was problematic, was he basically, he decided, he has this problem, right? If you're kind of dealing with this circular array of things, what do you do? But the inside is smaller than the outside, right? I got to figure out, well, how do I avoid collisions, right? Now, in his design, he basically said, okay, I'm just going to truncate the outsides, right? And that's okay if what you're doing is you are taking a slice through a something that where the difference in the outer radius and the inner radius isn't that large. And in fact, in his video, he takes it through this sort of truncated sphere sort of shape that he designed. And it gave him a nice sort of curved surface with a hexagonal texture on it. But what I wanted to do was be able to sort of use this to sort of punch holes through a rounded rectangle extrusion, right, in this hexagonal pattern. And here, the distance, the radius in sort of the outer corner is a good bit larger than the sort of the center of the flat face. Like, those are pretty different. And if you go back and sort of look at his design, like, they're hexagons on the outside, but if I go look at the inside, because he's truncated them, they're distinctly not hexagons. They just ain't hexagons no more. So I initially tried this with my shape, and you end up with this sort of monstrosity here. If I can get this thing lined up just right, you'll see that at the corner, if I can line those up, yeah, it's actually a pretty good approximation. Like, that's a hexagonal grid. But the closer I get to the inside shape, which I can sort of just line it up right on either the left or right face, it's just hideous, right? It's not, they're not hexagons, it's not even a pattern. It would not print because some of these places where they overlap are too close together. And so he kind of made this assumption that, like, he was only going to really use this as a texture on a surface. And I was trying to do something different. So I decided, okay, let me take a stab at fixing that. And instead, I came up with sort of this design where what I was going to do is I was going to taper them instead. And make sure I got the right thing here. Turn this off, and you can sort of see. I basically took his original sketch, and instead of extruding it and then truncating it, I extruded it and then tapered it. But the problem is that the taper draws all the faces in towards essentially away from their normal, and so they don't collide anymore. If you were to look at these, very carefully, I've chosen a value for the taper that's just small enough that they don't touch. There's a little tiny gap in between. Either way, the extrusions for sort of a matching pair. So a matching pair should be parallel. Like, they should remain a constant distance from each other, center to center. However, that's kind of not what I want, right? I'm trying to extrude these things into sort of a cylindrical space, and they ought to get closer together. And in fact, the spacing of the different layers ends up being completely wonky, and there's a place where they literally cross over each other. And so as a result, if I were to take a cut out of this surface, again, on the corner, it looks good because I've sized it to be just slightly larger than the rounded rectangle prism, but closer to the center where they cross over, there's a point at which they're basically touching. And so that would not work well for a 3D printed application. Not to mention, it kind of looks stupid. It's clearly kind of was intended to be a grid, and it's a grid on this, it's much more gritty on the narrow face than it is on the flat face, and it gets to a point where they're basically just lines. And so so that didn't work, and so this was when I started over, and I said, look, I'm just gonna take what I learned from doing his designs, and I'm going to come up with my own approach to this. And so I'm going to take a moment to sort of talk through that, but first I want to sort of say, have a little digression about best practices, because to me it's really important to sort of think about design intent. And so as a best practice, I think one of the things that I recommend for every model that I do in FreeCAD is I always start off with three things. I start off with a text document embedded, and I've renamed to be notes, and then two spreadsheets, one renamed to be P for parameters and the other renamed to be M for measurements. And this is the notes page, and again, you can find this into the tools menu where it says add text document. You can just add a text document. It doesn't really affect the rest of your model at all, but it gives you a place where you can put your contact information, your copyright information, the licensing information for your design, any design notes that you had, limitations of the design, things about the process, assumptions that you made, anything that might be a gift to your future self 2 years from now or 5 years from now when you come back and want to revisit this design and use it for something else. Or if you're giving it to somebody else, or somebody else is going to come along and try to maintain and adapt this design. Being able to understand what you were thinking about and get in the same frame of mind to capture that design intent. Write some notes down. I can't, so many times, and I come from a software engineering background, and this is like writing comments in your code. So the second thing is this idea of having a spreadsheet. Anything where that any numerical value in your spreadsheet where you got out the calipers to say, okay, well, how big is this gap that I need this thing to fit in, or what's the space, or a ruler, and you said, I'm going to have this, or tape measure, whatever it might be. You know, maybe I'm interfacing with something else, and I got like some kind of spec sheet that I'm going to, you know, has the measurements on there. Any value that you might want to change later, or you're going to refer to throughout the model, and you want to, and it has a sort of a conceptual meaning, I recommend you put that in a spreadsheet. Rename the spreadsheet P for parameters, the one letters because it's easier to type, and give it a name. How do you think about this thing? This is the outer radius. So I have a column A here is the name that I gave all these different values. O for outer radius, R reps for reps, like the number of repetitions. Gap, so that's a measurement, that's in 4 millimeters. And then I had a value for the Z repetitions, right? So I had reps, meaning how many times does it repeat going around the cylinder, but then how many times does it repeat going up? And initially I saw that as a parameter. Later I said that doesn't capture design intent, as well as, because I might vary some other things. Like I might, if I vary the size of the hexagons, then how many times it repeats is going to also vary. So let's instead specify a target height. Like I want it to be as close as possible to 200 millimeters, which is what I've kind of got specified here. And then I wrote a formula based on that for, okay, how do I compute? Well, how many repetitions would that be? It would be, in this case, it turns out to be 7. And if I were to change this value, my entire model just kind of recomputes itself. And then there's some values that you can just compute based solely using geometry and high school algebra without using a sketch. In this case, what is the distance between repetitions in sort of the XY plane, the sort of what I call the X distance per repetition. I named it XD rep, and that's just the circumference of the cylinder divided by the number of repetitions, right? So if I've got 300 millimeters as my outer radius, then 30 repetition, that turns out to be 62 millimeters, right? And I don't really care, because to me, it's a symbolic value. It's XD rep. And if I were to change some of these other parameters, I can change it. And in all of the sketches where I used that, it'll just cascade through. And then similarly, the M for measurements spreadsheet is any values that I want to reuse. It has some sort of conceptual meaning that is meaningful to me as a designer, but it's pulled out of a sketch. There's a reference constraint that is measuring this for me. And so those actually could be theoretically in the same spreadsheet, but there's limitation of FreeCAD version 0.19 and earlier, where it kind of can get confused if you have a spreadsheet that defines a sketch, and then the sketch is also defining values on the spreadsheet. It considers that to be a circular reference, even when they're technically not, because they're like different cells in the spreadsheet. But it's a little bit not sophisticated about that, and apparently causes problems, or so I've read. I actually just avoided doing it because somewhere on the internet somebody said don't do that. So step one for me is just sort of filling in this spreadsheet and sort of defining what are the values that I want to capture, and give some first guesses as to what do I think those things are. And then step two was go draw the sketch. And so let me show you this, my sketch. So I drew a single hexagon grounded against the x-axis, centered on the z-axis, and then these 3 reference hexagons. And you're thinking, 3 reference hexagons? What do you need all this for? Look, reference hexagons and reference geometry of any kind is free. Like, if it helps you to think through the problem, just go do it. All right. So, and these all serve some purpose, if minor purpose in some cases. So, the first thing I want to note is that I'm sketching this hexagon on the right is there specifically so that I can use this corner. And this is sort of avoiding the mistake I talked about earlier in JOKO's process, where I'm constraining that to be, and if you've never seen these constraints be orange before, it's because that's the way FreeCAD colors a constraint when it is referencing some external function. So this is a reference to the spreadsheet. Literally, if you click in, it says it's 62.83 millimeters, but if I open it up, the formula for it is p.xdref, right? So this is literally, I'm just pulling this value from my spreadsheet where it's computed, and that's setting my bounds, right? And this is sort of equivalent to where JOKO said, I'm going to draw this sketch that's a wedge. I'm like, okay, I can just compute that. And I could have also probably drawn a sketch that was a wedge and said, okay, well, the wedge is going to be however many repetitions, it's going to be a circle divided by that. But to me, this was easier. And so, so this is here to get the spacing right. This middle hexagon is here to kind of position this one correctly so that it's in the same grid. And much like JOKO, I kind of have defined these little tiny reference lines in between to specify the gap. And then this, and those are all just set to be perpendicular so that they're straight across the gap. And then this hexagon on top is important, at least in part, because what I want to know is what's the vertical distance, right? And similarly, I set that as a reference constraint, and then I give it a name. I call it Z distance per repetition, or ZD rep. And then that gets copied over by reference into the measurement spreadsheet. So similarly, column A is the name, column B, it has its own, the same name, right? It's ZD rep. That way I can refer to it in a formula by name. And its value is actually a reference back to the sketch. It's sketch.constraints.zdrep. And so by doing it this way, I can refer to it without having to remember which sketch did I pull it from, because sometimes in these designs, like I got a whole bunch of sketches, and they're all, the default names is sketch 001, and so I don't have to remember if it was in sketch 005 or 006. Like, I gave it a name in the spreadsheet because that, of all of the constraints that I had, this is the one that I thought was worth pulling over, and I know I'm going to reuse it. And if I'm ever coming back to study design, I can look and see, hey, here's all the values that I got that I reused. Now, and then if anything, there's actually a bunch of these other things: the radius face to face, the radius point to point, the length of a face. I thought I was going to need those, and I didn't, but they're all in here, and they're all just pulled off of that same sketch. Just these sort of other values that are in here. Now, before I do my extrusion, I need to know what the taper angle is. And so that was tricky, and I initially kind of did it with trigonometry, but why do trigonometry when the computer can do it so much better? So I created this other sketch that I eventually renamed taper angle, and again, it's very simple. It literally is just I'm sort of sketching the taper on the sides. Here's the hexagon, and then I drew these two sides as reference lines in it. And the distance there is, again, is the outer radius, which is, again, is a reference to my spreadsheet. And so the whole reason I was doing this is basically to capture this reference here, which I gave it a name. I called it double taper, right? Because it's by similar triangles, and again, sort of high school. I should have measured this distance between the taper and the horizontal axis, but I actually just I measured this instead. But it's okay, because then when I copied it into my measurement spreadsheet, here I named it taper, and I knew that, like, okay, what I had captured in the sketch was a double taper. There's no actual geometry that comes off of that sketch. It's just there to be able to show, okay, here's how I compute what the taper looks like. And so now I'm basically ready to do my actual 3D geometry. We're pretty much ready to go. So I take this and I'm going to extrude it. And when I did the extrude, I specified a taper angle, and I specified a distance. And again, that distance is 297, but it's not really 297. It is 99% times the parameter for the radius. So it's p.o radius times 0.99, right? And so that is a good way to capture design intent. I see that 99% and I think, I didn't want it to go all the way, probably because I was trying to avoid having a zero size face on the far end. And so I have it go 99% of the way, which is going to always be good enough. And then The other thing that I had to specify is the taper angle, and again, I've already figured that out by pulling it as a reference from that other sketch and then storing that in the spreadsheet. So if I scroll down here, here's the taper angle, and the formula for it is negative m dot taper, which turns out to be 3.08 degrees. But again, I don't care. The computer's already computing that for me. So now we're pretty much ready to go, and I can take that extrusion, and I can do a polar array to sort of create a shape that sort of looks like this. It's, the cylinder, and then in the draft workbench there is a rotate tool, and if you select something and click on a rotate, it will give you a little checkbox where you can say, okay, I want to rotate that, and I want to make a copy as I do it. And I'm going to close that. I'm going to sort of cancel that out. But that allows me to basically do a copy where I had this first, what was now shown in gray, and I created a copy, and I rotated it and translated it in the Z dimension at the same time. And I'll show you how I did that, which is essentially that, again, I kind of did it, when you do that, the dialog box for creating a rotated copy, that rotate tool will let you specify values, but it actually will not let you specify them by formula. And some of the tools I've found in FreeCAD do this, where you can use formulas to compute things, various different values, but only if you go back and edit it in the properties box. If there's a little wizard that'll walk you through it, sometimes it doesn't let you type a formula in. Sometimes it does. So the angle here is 6 degrees, but it's not really 6 degrees. It's 360 degrees divided by the number of reps divided by 2. So that's how many times around. And then the divided by 2 gives me just a half a shift over, because I'm kind of drawing these prisms that are shifted, again, half a rotation. And then the position is the same in the XY dimension, but is shifted up in the Z dimension by the measured Z distance per repetition that I computed in that very first sketch where I sketched the hexagon, and I pulled a reference constraint off of that as like, okay, here's the Z distance between repetitions, and then how I used it in the sketch, and then I defined it in the sketch, and then I'm using it in a operation like a rotate as an offset. So that's that, and then the remaining step is to sort of do a union to fuse those together into a single object, and then to do a orthogonal array in the Z dimension to create my final shape. And so that gives me, if I come back to my ultimate project here, and so that gave me my final design, which is this. And so you'll see that the spacing of the hexagons appears right throughout, and so it's the hexagons are larger the further out the radius is. So on the rounded corners they're large, in the center of the flat face they're small. They remain hexagons in all cases, or like slightly tapered hexagons, because they're slightly smaller on the inside of the shape than the outside, but the walls are pretty thin, so that there's not much of a difference there. And visually it looks like the pattern is regular, even though in reality these actually are closer together, but they're closer together by the appropriate amount that they would be if everything was sort of radial, because they literally were defined as being radial prisms that are sort of shooting out from a central axis. And so that mentally looks good, and at least it looks good to me. And that was what I was trying to achieve. So the lessons to pull out of this, to kind of summarize, is to kind of go back, anytime you're defining a repeating pattern, it's useful to make sure that you're taking the same point on the next iteration, and don't get fooled by some other thing that happens to be close to it, or sort of seems like it's just the outer bounds, because sometimes the patterns will overlap slightly. That's the way a hexagonal grid is, depending on the spacing. Second lesson is, try real hard when you're using a tool like FreeCAD to capture your design intent, and techniques for doing that involve having a notes page where you can put in sort of human readable text that sort of shows you what your design intent was, but then also try to capture the important values in a spreadsheet, and use symbolic names for both your sketches, for parts of your model. Sometimes I do that sometimes, I'm not very consistent, but also just for the values that you're using as reference constraints or as values in the spreadsheet, and then kind of have a way to do that. And then the last lesson I think is interesting to take out of this is just there's more than one way to solve a problem. And so JOKO did this amazing video, and it was really instructive to me to watch it. But in the end, I ended up doing it differently, but achieving kind of similar results that worked better in this particular application. So thanks. Don't forget to be awesome, and don't do anything I wouldn't enjoy.